Hey there, welcome to my YouTube channel Physics and Ethics. Here in this video, I am going to give you detailed solution of September 2020 CSIR-NET Physical Science. So basically in this part, I am going to give you the solution of mathematical physics, and gradually we will discuss more and more topics. So let's first discuss this mathematical physics one. First question. Two n cross n invertible real matrix A and B satisfy the relation this. Okay. So basically there is A B equal to minus. Now if B is orthogonal, that is orthogonal condition is what? B into B transpose will be equal to I. This implies B transpose equal to B inverse, then A must be. So basically by solving it, now by opening the brackets, opening this bracket, we will got this as B transpose A transpose minus B inverse A. Now it's given that what? B transpose equal to B inverse. So this will become what? B inverse A transpose equal to minus B inverse A. Now multiply B on both sides. Then we will get what? B inverse A transpose equal to minus B inverse A. Now B into B inverse equal to I. So A transpose equal to minus A. So A transpose equal to minus A means this is a skew symmetric or anti-symmetric matrix. So the answer will be D. Answer is D. Next, the value of the integral this where m is a positive integer is. So this is basically a formula based question. So we have a formula for gamma function as x to the power m minus 1 e to the power minus a x to the power n dx integration 0 to infinite is equal to 1 by n gamma m by n whole divided by a to the power m by n. This is a very useful formula for all, like for mathematical physics, quantum mechanics, and all kind of things where we use various complicated integral. So now according to the question here, m is equal to how much? 0, n equal to 2m, and a equal to 1. So by solving it, we got 1 by 2m gamma m equal m equal to 1, not 0. Like 1 minus 1 is 0, that's why x to the power 0 is 1 here. So m equal to 1, n equal to 2m, a equal to 1. So it will be gamma 1 by 2m whole to the power a means 1 whole to the power 1 by 2m. So it will be 1 by 2m gamma 1 by 2m. Now in order to match with the option, so basically our integral have become 1 by 2m gamma 1 by 2m. Now in order to match with the option, we have a formula like gamma 1 plus n is equal to how much? n gamma n into gamma n. Like that, gamma 1 plus 1 by 2m will be 1 by 2m into gamma 1 by 2m. Okay, so this integral has become gamma 1 by 2. Now this is gamma 2m plus 1. So 2m plus 1. So the answer will be, answer is C. You can check it. The answer is C. Next, if z is equal to I to the power I, okay, then a possible value of 1 by z longitude. This is basically a simple question. Given z equal to I to the power I to the power I to the power I to the power like this, and it is given that the exponent continues to indefinitely. So we can write z equal to I to the power z. Now taking ln on both sides, ln z equal to ln I to the power, sorry, ln z equal to ln I to the power z. This implies ln z equal to how much? Z ln I. So 1 by z ln z will be equal to ln I. So we see this is basically the answer. So the answer will be B ln I. Next, 4 students make multiple measurement on length of the table. The bean data are plotted as histograms in the following figure. Okay, there are 4 students like x1, s2, s3 and x4, and they have what? Make multiple measurement on length. Okay, length of the table. They have measured 1 minute. Length of the table. Okay, the bean data are plotted as histograms in the following figures. Okay, so this is basically of x1 s1, of this is basically of s2, this is basically of s3, and this is of s4. Now it is given that if the length of the table specified by the manufacturer is 3m, okay, the particular length is equal to 3m, the particular length is equal to 3m, the student whose measurements have the minimum systematic error. So this is basically a very simple question. Student which have length calculation nearly equal to 3m, that is the length calculation, the probability of finding the length is maximum at 3m. That student must have what? Least systematic error or minimum systematic error. So you just check, like for s1, the length is peak at 3. For s2 the length is peak at 5 or 4 something. For s3 the length is peak at 5, and for s4 the length is peak at 5. So basically for s1 the length is that is the measurement is peak at 3. So the answer will be nothing but what? The answer will be nothing but of s1, that is option B. So this is basically the answer. Next, at z is equal to 0, the function this of complex z has, okay, so it is asked about a pole and the order of its pole. So in order to find that, let's first find the pole of this function. Okay, so to find the pole, z minus equal to 0. Okay, z equal to sin z. So basically this condition is valid for z equal to 0 only. So the pole is nothing but z0 equal to 0. Now let us find the order. Now in order to find the order, let's expand this what? F of z equal to given 1 by z minus sin z. Let's expand this sin z. Now by expanding we got like 1 by z minus zq by 3 factorial plus z to the power 5 by 5 factorial. I can write another term also, z to the power 7 by 7 factorial. Next, f of z becomes 1 by zq by 3 factorial minus z to the power 5 by 5 factorial plus z to the power 7 by 7 factorial. Now by taking common zq, we got 1 by 3 factorial minus z to the power 5 by 5 factorial plus z to the power z square by 5 factorial, z to the power 4 by 7 factorial. Now this let's put at the pole at z equal to 0. This term is not 0, but this term is 0. Hence the pole z0 equal to 0 as order equal to 3. Okay, so the answer will be D. Next, the infinite series. 1 minute. The infinite series, this at x equal to 1 by 2. So we have to find this infinite series. Okay, so in order to find this infinite series, let's evaluate this term by term. Like let's evaluate first this n square. So I'm first writing it like n equal to 0 to infinite n square x to the power n plus epsilon n equal to 0 to infinite, or I can write like n square x to the power n plus 3n x to the power n plus 2x to the power n. Now in order to evaluate this, I can directly put x equal to half. Like we don't know the value of half to the power n. So let's find it terms by terms. So first term is n square x to the power n. Now the n square x to the power n can be completely written in terms of x as x d by dx, x d by dx, x to the power n. Just check it. Like differentiating this will be n x to the power n minus 1. Again by multiplying x it will be what? N x to the power n. Again differentiating it will be n square x to the power n minus 1. Again multiplying by x it will be n square x to the power n. Okay, so we can write n square x to the power n as this. Next, the second term is 3n x to the power n. So in order to do that, let's write it as 3x d by dx of what? X to the power n. So d by dx of x to the power n is n x to the power n minus 1, and multiplying x it will be n x to the power n. So it will be 3n x to the power n. Next is 2x to the power n. So 2x to the power nothing but 2x to the power n. Now let's write the what? Infinite series in this way. How much? N equal to 0 to infinite x dy dx, x dy dx of x to the power n plus bracket plus 3x d by dx x power n plus 2x to the power n. So the sum will become like x s d by dx to s d by dx summation n equal to 0 to infinite x to the power n plus again 3 x d by dx of n equal to 0 to infinite x to the power n plus 2 n equal to 0 to infinite x to the power n. Now n equal to 0 to infinite x to the power n is nothing but a GP series, that is 1 plus x square plus x cube plus dot dot dot, where the first term is a equal to 1 and the GP r equal to what? X. So the GP series will become what? So the GP series, that is, so the summation term becomes 1 by 1 minus x. Now s equal to, we have dy dx 1 by minus x plus 3x d by dx of 1 by x plus 2. So by solving, got x d by dx, it will be x 1 minus x whole square 3x 1 minus x whole square plus 2 by 1 minus x. Next, this will be again s, it will be what? 1 minus x whole square plus 2x 1 minus x divided by 1 minus x whole to the power 4 plus what? 3x 1 by 1 or we can write like 3x 1 minus x whole square plus 2 by 1 minus x. Now at x equal to half, the summation becomes 1 by 2 to 1 by 4 plus 2 into 1 by 2 1 1 by divided by 1 by 2 whole to the power 4 plus 3 by 2 1 by 2 whole square plus 2 by 1 by 2, so it will be plus 4. This implies s will be equal to 1 by 2 1 by 2 whole to the power 2 by 4 plus 3 by 2 2 square plus 4 1 by 4 plus 1 by 2 4, so it will be 3 by 2 16 3 by 2 into 4 it will be, so 6 plus 6 plus 4 16, answer A. This is the answer. Next, the matrix corresponding to the differential operator 1 plus d by dx in the space of polynomials of degree at most 2 in the basis spanned by f1, f2 and f3. So there is a differential operator 1 plus dx d by dx, and there are bases like f1, here I am writing this, like f1, f2 and f3. So this differential operator will operate on these bases and it will give a matrix in the form which can be, I'm just writing the form of the matrix here, then we will solve. So this will be like, we have to first write f1 values, like what the operator do with f1, then f2 what the operator do with f2, then f3 what the operator have done with f3. So what we will do basically, first let's evaluate the operation on f1. So it is nothing but 1 plus and all the value will be 0, so we can write this as 1 into f1, 0 into f2 and 0 into f3. Next 1 plus d by dx on f2, so it will be like x plus 1 plus 0, so we can write it at 1 into f1 plus 1 into f2 plus what 0 into f3. Next 1 plus d by dx operating on f3, it will give a values like x square plus 2x, so it will be like 0 into f1 plus 2 into f2 plus 1 into f3. Now you must be thinking why we are writing these things in the form of this, because in the matrix we have to, because in the answer we have to written in the form of matrix, and in order to write in the form of matrix we need the coefficient of the basis, and the basis are this basically f1, f2, f3 and coefficient at 1 0 0. So to know the form we need to write in this form, okay, and the matrix will be like as I said, on f1, on f2, on f3. So what 1 plus d by dx or the operator done with f1, it will be like 1 0 0. What with f2, 1 1 0, and f3 like 0 2. So this will be basically the matrix after the operation on f1, f2 and f3, and the answer is like A. Next, the value of integral this for alpha is greater than 0. So basically we will evaluate this using complex analysis, that is this is nothing but real integral part of the complex analysis. So basically, if we have a axis like this is 1 minute, this is a real axis, this is imaginary axis. Then for real integration, we have a curve, we have a semicircle like this, and which is extended. This is like minus a, and this is plus a. This is imaginary. But like this is real part, that is x, imaginary part like y. Now when like this, the limit is minus r to r, here the limit is minus infinite to infinite. So when this limit is extended to minus infinite to infinite, okay, so the whole contour integration, like the whole contour, like this is a contour, okay, where this is the semicircle part and this is the line part. Okay, so the whole contour will be what? F of x dx minus infinite to plus infinite plus f of z dz of the semicircle. Now we all have studied in our BSc complex analysis topics. This thing will be 0. So this will be a lengthy thing, that's I'm not saying here. So but f of x dx from minus infinite to infinite will be equal to f of z dz from z dz along the contour. Okay, now we have certain condition to use this formula. There is two formula exist for this kind of real integration. Like we all have the formula for f of z dz equal to 2 pi I into summation of residues. Okay, so this is the basic formula we all have. Now for this real integration thing, it will be equal to two formula we have, pi I into summation of residues is on real axis. So this condition, this is the condition for pole lying on real axis. Now the second is this is equal to, the second part is 2 pi I summation of residues on upper half plane. So this is basically the condition for pole lying on imaginary axis. Okay, so this is basically two conditions. This is first, the condition is like this is first, this is second. So for that we have to first evaluate the pole. Now we have the integration I equal to f of x dx. Integration is equal to what? Cos alpha x square plus 1 dx minus infinite to infinite. Now let's do like this. So this is nothing but equal to what? Cos alpha z square plus 1 dz of the contour. So I is equal to, we can write real of e to the power I alpha z divided by z square plus 1 dz. Now let's find the pole. So pole can be evaluated like this. So z will be equal to plus or minus I. Now this is basically a pole lying on what? Imaginary axis. So the formula I will be equal to 2 pi I into summation of residues in upper half plane. So here the pole which is in upper half plane is I. Now we have to find the residue at I. it is b1 at I. So b1 at I can be, but this is basically a simple code. It will be limit z tends to I, z minus I whole into what? E to the power I alpha z divided by z square plus 1. Okay, like this. So this will be limit z tends to I e to the power I alpha z divided by z plus I. So it will become e to the power minus alpha divided by 2I. Okay, so this is basically the residue. So the integral will be 2 pi I into the power minus alpha by 2I. So it will be 2I got cancelled, pi e to the power minus I alpha. The answer is B. Thank you all. Let's meet in the next video.